Hey there, everyone. Ryan Schul here. Welcome to my channel. So today I want to take you through a project where I worked on an AI process to use GNN for insider trading pattern detection. So this isn't going to be AI like ChatGPT or Hugging Face or something like that. That could be another approach. It's totally fine. It's just a different perspective on things. But we are going to use one form of AI, which is called GNN. This is a graph neural network. And there's a few I guess a few approaches to this kind of problem. I'll discuss the approach that I chose, but like some type of AI, artificial intelligence, could probably solve the problem pretty easily, right? Using some form of machine learning, deep learning, natural language processing, maybe even computer vision. There's many ways to skin the cat, right? We have different machine learning tools in the toolbox. We can use a subset of AI tools under the machine learning umbrella. We could use deep learning. That might work as well. Probably the performance will probably be slightly similar, but ultimately somewhat the same, right? But if you test these different models, you're going to get slightly different results because the math is different, the stats is different, the inputs and outputs are a little bit different. But in this case, I chose GNN. I like these GNNs. I've worked on this a lot in the past, and you can find a lot of GNN graph neural network related topics on my channel here. So let's jump into it. Let's take a look at this topic. Basically, we're going to combine data from this data source. This is called insider trading. It comes from FinViz. So I have a few videos about this FinViz website. I like it a lot. I think it's pretty interesting. They have all kinds of screeners, maps, news, obviously lots of ads. Ads are always popping up in your face all the time. News, home, maps, groups, portfolio. So, okay, and that one's dead apparently, just as I click on it. So that's nice. News feeds, right? Tons of stuff here that you can jump in and get acquainted with your stuff, right? They have a couple of charts over here, top gainers. I like this a lot. If we go to MSFT and hit enter, I've discussed this on my channel on a couple other pages. You can look at fundamentals down here. So these are, oops, let me get rid of this. Yeah, so many ads here, so many. So here's a bunch of fundamental metrics. We have books, book share, price to book, PEG ratio, EPS, ROA, ROE, ROI, things like that. So that's very comprehensive, right? So I use this as a source for my data. And like if you're interested in all those technical indicators or fundamental analysis, I have videos on both of those topics. You can check those out on my website. Today, I want to look specifically at insiders and try to understand, are there any kind of unusual or weird patterns with inside trading activity? Now, this is not the insider that trades on information that is not disclosed publicly, right? Like if you know that two companies are going to go through a merger, the bigger one buys the smaller one, the small one will probably be bought at a premium, and the stock price is probably going to jump up almost immediately after the transaction to the differential between, what the fair market value price of that enterprise was and the price that was paid, right? So you see this all the time. Companies have a 20% boost after the transaction is done, 25%, 30%, whatever it is, right? But you can't trade on that. That is illegal, guys. Okay, so we're not talking about that kind of insider. These are insiders that have enough stocks that they can have almost superhuman like power to control different different things like the board, influence high level decisions about the company, and potentially um, drive the stock price up and maybe drive the stock price down if you're doing a bad job. But that's what it is. So this is totally legal, it's totally legit. There's a form called, I think, SEC filing form 4 or something that has a lot of this information on it. Let me just look at this real quick. Insider SEC form 4. Yes, this is it. So with form 3, 4, and 5, I think most of the insider transactions come from form 4. You can look that up. So my point here is originally my first attempt at this was to try to scan through a bunch of XML files, HTML files, all kinds of documentation from the SEC. It got really messy and really it just really didn't just work out too well. So I kind of got away from that and just went right to the insider information from FinViz. So this is pretty clean. I like the layout here, very crisp, very tight. So rather than scanning through a whole bunch of documentation, which really didn't even really work that well anyways, it was kind of buggy to tell you the truth. I just went to this resource and it looks pretty decent. So I'm going to go with this. And it looks like a pretty reputable site, so I'm not going to go ahead and validate everything over here, but if I go to this company, we should see some basic insider information. AEHR is the ticker, right? Finance, AEHR. Let me see if I can find a couple of these insiders. Aher Test Systems. I've never even heard of this one, but that's fine. That's fine. Sporek Alisar. Let me look for this guy over here. So I forgot where Yahoo Finance keeps this, but let's just spend a couple of moments. Financials might be holders, options. It's not sustainability, I don't think. Maybe holder. Ooh, no, that's entities that are invested in this. Maybe financials, but I don't think so. Analysis holder, options, analysis. Maybe profile. They'll tell us the location, some of the key stakeholders here. Okay, so I don't see what I was really looking for, but these are like the key executives over here. Anyways, I might have changed this around a little bit, but okay, it's a pretty reputable source, Finviz. So I'm just going to go ahead and rely on this. I set up a screen scraper using user agent to go ahead and help the whole process look like it's a Mozilla browser logging in. If you don't do it this way with the headers and simulate a browser doing the login and screen scraping, they're going to flag you and you're going to not be able to grab this data, right? Or I suppose you could do something like this. Right, log into the site, go over here to ticker owner. Okay, scroll down here, and let me paste that into Excel. Okay, so I'm going to open Excel, save that as a CSV, and then I can read in the CSV into my data frame. So that's another option to fetch this data. So this is opening right now. Okay, 100% looks good. Okay, and go ahead and paste in the data from my copy. There's a copy paste. Okay. Oh, it looks fine. And then I'll save it as a CSV. Okay, so that looks good to me. I can put it on the desktop, I think. Desktop is good. Save it as CSV. This is going to be MS-DOS. Do raw data. My cap box is not in with that. Okay, it doesn't matter. Okay, then if I go to my desktop, raw data, and open this, I can read that from the CSV. Wait a second, why is it formatting there? And why does it say sheet one? So this is weird. Give me a second, guys. This is weird. Well, data is spelled wrong for one thing, but that shouldn't matter, right? Like, let me TA. Is this actually a CSV or is this something else? Give me a second here. So, okay, now it's a CSV. Okay, I can tell because the tab name matches the name of the file, right? And all the formatting is gone. If you think about it, CSV is basically just a text file. We're opening it through Excel. So that's why it kind of looks like Excel, but it's basically just a comma delimited value right here, right? And they did see some little buggy things like you have upgrade to Finviz Elite as a row, upgrade to Finviz Elite as a row. So that looks kind of funky. I don't know where that's coming from, but I did notice when I copy pasted, I get about 203 records, 204 plus the header, so that's 203. So that doesn't belong there. That doesn't belong there. And there's one more that doesn't belong there either. So anyways, you could do that. I think it's very clunky. If you do the screen scraping technique, I think it's just a lot more sexy and faster too. Okay, so that's why I chose that. So anyways, we got the screen scraper to work, and here's the header right here, 200 records. And I can go ahead and let's see, I'm going to convert this date right here to an actual date. So this could be a date. I can't tell. If I go back and look at the data types over here, it'll tell me actually like yes. Yeah, these are all objects. So the date is actually an object. So first thing we're going to do is convert the date to an actual date. So we use pandas date time to convert that to an actual date. It's going to be month, day, year, right? And that's how they represent that over there. And then we have trade date as an actual date down here. And I'm getting 1 month return before today's date. So we're going back in time to get the 1 month return. I want to see if the stock price is up, down, or sideways. And I want to determine if there's a price spike. So it's just a couple things we're doing here. Okay, I'm going to delete this and I'll share all this code with you guys by the end of the video. When I post the video, I'll post the code. So there's like 3 things basically that we're doing here. We're creating a trade date. So appending a new column to the existing data frame. So here's the existing data frame. This is what it looks like. Create a new date. We are going to get all the tickers from FinViz. So we're going back to this data frame, getting all the unique elements in that field right there, and we're converting that into a list that we will feed into Yahoo Finance to download all the tickers and have a start date and end date, right? So I have a between date or 2 dates, and I'm querying everything between the trade date minimum minus 2 months. I'm going back in time 2 months, and the end date is going to be basically today minus 2 days. So going back in time 2 months to capture all the transactions over here. And it is now, what's the date today? July 15th. And I see some trades going back here. If I sort this in order, it shouldn't let me do that, I think. Yeah. Oh, no, it doesn't. It doesn't. Okay. So I can just eyeball it here. It looks like there's a few dates, a lot in July. I thought I saw some Junes. Maybe my eyes are playing tricks on me. July. These are all July trade dates. Okay, so it's totally fine. All I want to do is make sure that I go back far enough to capture all the closing prices for each of these tickers in this list. Okay, so I hope that makes sense. So we're going to this data frame, right? This whole data frame. Everything's selected here, 200 rows and 10 columns. I'm looking for this ticker. So I found the ticker. I'm taking the unique ticker. Okay, that is going to be my list of tickers, and I'm going to loop through all of these tickers. So for ticker in tickers, this can be anything. This could be Ryan, that's my name. This could be I like to keep it somewhat relevant to what we're doing. So we're looking for tickers for each ticker in tickers. That's going to be the loop. We get the closing price, and again, we're going between the start date and the end date. So if I can do control find, start equals start, end equals end. So hopefully that makes sense. I'm going to pull in all those prices for the last 2 months. Again, that is enough coverage. We don't have to go back years. To go back years would just take more resources, more time to do the fetch, and we would just ignore 90% of it. It doesn't make any sense to go back years. 2 months is going to capture everything that we need. We're fine. We have everything covered back in time 2 months, and we can go ahead and append this onto the data frame. So remember, the original data frame looks like this: ticker, owner, relationship date, transaction cost, number of shares, value, number of shares total. So I think this is after they redeem these shares. So I think this guy is selling 15,000 shares. If you multiply 3166 times 15,000, you get that 47,000. So, well, Amanda, I can't tell if that's a girl or a guy. Sorry for that. Wellen, not sure. But this person, anyways, has redeemed about 474,832. That would take me about probably 50 years to make that kind of money. So that's a good chunk. But that's how you get that 474K. So cost times number of shares, you get that. Number of shares remaining, so 517,831. Wow, this person is swimming in it. Whoever this is, like, wow, you made some good decisions in your life. I made some not so good decisions, but congratulations to you. Keep doing whatever it is you're doing. So presumably that is after the redemption of the 15,000 shares. I guess I didn't really look into it, but number of shares total, I think that is the current ownership of shares. So that's how we interpret that. Hey, now you have all of that stuff over there. And then these are the new fields that we created. There's a trade date, and this is actual date, 1 month return before this transaction took place, right? So we're going back in time, July 11th, 2025. We're going back about 30 calendar days. There's 22 trading days on the calendar. Every month we have about 22 days for the stock market to be open because it's not open on the weekend, right? Every Saturday and Sunday is closed, and on major holidays, so Christmas, Thanksgiving, New Year's, what else? Labor Day, 4th of July, Memorial Day, the exchange is closed. So for about 11 days out of the year, it's closed, plus the weekends, right? So that's why we get 22 trading days. So going back in time 1 month, and we're looking at whether or not there's a price spike. I'm saying if it's greater than 10, then I want to know if then tell me there's a price spike. So if it's less than 10, no spike. If it's greater than 10, then there is a spike. And this is kind of an arbitrary metric that I just came up with. It doesn't have to be 10. It could be 5, it could be 8, whatever it makes sense to you. But I want to set up some kind of flag here to determine if there's a spike in the price going back in time 1 month. So we get the 1 month return. If there's a spike, I want to know about it. And I set this to 0.10, so 10%. Again, kind of arbitrary. It can be 5%, it can be 8%, whatever you think. I said 10%, I'm going to go with that. So now I'm going to use a method called graph analysis. So this is very popular if you are trying to look for relationships between non-structured data points. So all your friends on Facebook and all your friends of your friends and all your friends, if that makes sense. So that is what network graphs are good at, looking for all the nodes and all the edges between all of these relationships. So a node represents the entity, such as the insider, a stock ticker, a date, something that can be represented in this data frame over here. Okay, so these are all nodes. An edge is basically like the relationship between all these things. Okay, so executed a trade on this date, filed Form 4. I showed you the Form 4 earlier. Okay, owns stock, traded stock. Some other relationships, right? So the nodes are going to be all the circles that you see. You'll see a whole bunch of circles, and the edges are going to be the links between these nodes, okay? So let me go ahead and run it, and you'll see how this works. Okay, so again, I'm going to share all this code with you. You don't have to take notes. You don't have to memorize this stuff and write it down. But I think it's pretty cool. When you zoom in, I use PyViz to look at all the relationships here. So you can see this is very dynamic, and it moves around. The stock ticker is going to be represented by 2 or 3 letters, and then the individual's name is going to show up because they're associated with this ticker. Okay, so in this case, the ticker is PBI, and you had 2 people making trades. So this could be a buy or sell. I can't tell at that view, but the transaction over here will have that information, right? Proposed sale, buy, sale, and sale, right? So I think this is pretty cool. It's a good, definitely a good start here. You have 3 people doing transactions on Dell. So this person right here, and this person, which looks like an LLC. So it's kind of like some kind of structured entity, I guess. And then this person right here, which looks like an actual individual. So that's fine. I think we can level up a little bit and do a more thorough analysis, because all I see here is names of LLCs, apparently, and then the stock, and then sometimes people's names that are associated with buy-sell transactions of the stock. So if I go down here, I just refresh this, you'll see now this adds another dimension of intelligence, or just more data is divulged here. So you have a green node, which represents an insider. This is people. A blue node represents a ticker. That's a company. So red edge means sale. Green edge means buy. Thicker edge is higher trade value. And when you hover over it, you see details about the trade date. So let's take a look here. So this is Yum Brands. This is the person doing the transaction. Remember, green is an entity or an individual, or it can be an LLC. I think I saw one back here. Now I can't find it, but there was an LLC. Anyways, I'm sure you saw that. I don't know where it went, but it was over here somewhere. So typically it's a person, could be an LLC. The blue represents the entity or the stock ticker, right? If you put your mouse over here, you can have details like the date and then the transaction value. And then this is a buy. Remember, buys are greens, reds are sell. If you go over here, this is a sale on July 10th, 2025. The value is 0. Here the value is 0. Here the value is 0. Here the value is 0. And this looks a little weird. Okay, I don't want to give away too much information, but I think we're going to see this again later. So that's why we're doing this whole exercise. So look for insider trading pattern detection and look for these kind of weird anomalies. Like, why are all these people trading zero shares on the stock? Now, if I zoom in, I can get more access to that, right? But it takes a little work and a whole bunch of analysis and some due diligence to get there. That's why I put together the script. So the script is going to do a lot of the lift for us. So this is interesting too. This is a sale, right? Remember, reds are sales, and this is pretty big one too. So this is actually 1 billion in value, 1 billion 22 million. Okay, and I think this is Intel Corporation, the entity itself. So this is not a person, but it's almost like the company buying its own stock or selling its own stock, because the individual, which would normally be the person because it's in green, is actually Intel Corporation, and it sold stock to itself. Okay, so that's interesting too. I don't know why that happened, but let's go to the next step here and see if we can determine it. Okay, so in the next thing here, and it's hot here, guys. It's hot. Oh, okay. The only time I sweat is when it's 90 and above. I know sweat for this stuff. I think this data science and finance stuff is pretty easy. It doesn't make me sweat, but when the temperature gets up to 95 or 100, then I'm sweating. But yeah, this is kind of easy. So let's keep going. So this graph-based neural network, abbreviated GNN, is used to detect abnormal stock activity after an insider trades. We need to turn this testing, trading activity, as well as market activity, into data so we can make intelligent, informed decisions about this information. Remember, this was all zeros if you put the mouse over it. Transaction date was all July 10, right? And all zero values. So why are they doing this? This is very interesting. If I'm going to do a further investigation, I'm going to say, why are you selling all these stocks or exercising all these options at zero? This one's pretty big. Is this going to be determined to be an outlier? Yes or no? I can tell you it really isn't, because I've already done the analysis, but it does look suspicious. Like, the first thing I'd look for here is, why is Intel selling $1 billion worth of stock to itself, right? So that's a question that we might want to answer. And why are all these transactions worth zero down here? That's another question that we might want to answer. So we're going to go ahead and build a graph, right, to help us do the analysis. And we have the graph down here. We have all of the trade values, the trade type, and the timestamp. Again, this comes from DF FinViz. If I go back and look for this, Control F, remember the FinViz was the original name for the data frame, right? So here's the FinViz over here. There's the data frame, and we're focusing mostly on two things in the data frame, the owner and the ticker. So if you look at owner and ticker, you can see how we're looping through all of these elements in the data frame. Here's the owner and here's the ticker, right? And you saw that in the graph that I just showed you. You see the owner and the ticker, and we're putting everything together into this node, all these nodes, and this GraphX tool to kind of explode all of these relationships and see how everything is linked together. That's the purpose of this whole thing, right? So if we go down here, we're going to define the GNN model. So this is graph-based learning, graph neural network, to detect abnormal stock activity after an insider trades. And again, this is not illegal activity. This happens all the time. It's just a person with a lot of shares of stock that's considered a corporate insider. They have so much stock, when they sell it or buy stock, they can actually have an impact on the market. They can drive up the stock price a little bit or drive it down a little bit, or maybe even have like a real impact on the stock if you try to offload too many shares, right? With some of these big swinging guys like Bezos and Gates and Zuckerberg, if they dumped tens of millions of shares of stock, that's going to have a significant negative impact on their stock price. So if they want to offload stock, they're going to do it in small batches. And if they have a lot of money in cash and they don't want the stock and they want to buy it, they're going to push up the price of their own stock price and almost shoot yourself in the foot, because you're buying so much stock so quickly, you're driving up the stock price, and now you're just paying more for your own shares of stock, right? So they tend to do it in small batches and not move the market price of the stock too much, but you have so much influence and so much leverage well, maybe the leverage is not the right word because leverage kind of means something else, but so much influence and so much potential on that stock because you own eventually millions of shares, maybe billions of dollars of value of that stock, you can move the price. That's what I'm trying to say. So here I'm going to go through 500 epochs in batches of 10 at a time. So what's an epoch? When you get into these large, not LLMs, I'm sorry, when you get into neural networks like TensorFlow, PyTorch, GNNs, RNNs, CNNs, all these wonderful things that are out there, you go through iterations of testing the model and trying to help the model to improve, right? This is called Adam model. That's what it is. So Torch, the optimize the Adam, this is the model that we're working with. And you can see that the model is learning better and better as time goes on. So the loss is 5.0, then 2.1, then 1.14. Right now we're up to 10 epochs. So this is 100 iterations through the loop. We're going down here. This is about halfway through. This is 250 epochs, right? 250 times through the loop. And you can see the loss rate here, the learning loss, or how competent this model is in learning. This starts at 5% loss. Now we're down to 15% loss, 13%, and then just 11%. So you can keep going with these epochs if you want. I set this to 500. I think that's sufficient. You can do 5,000. You can do 10,000, 50,000, 5 million if you want. The compromise is, like, the model will learn a little bit more and continue to learn probably. Maybe it will reach a point where it can't learn anything else, but you're going to chew up a lot of computer resources and a lot of time if you go through tens of thousands or hundreds of thousands of iterations, right? If the model is going from 5% loss down to one fraction of 1% loss, so just over 1% loss, right? 1.1% loss down here, I'm saying it's probably good enough. It's going to produce a good result in terms of the anomaly detection and with the output that it's going to feed to me, and I'll be able to make an intelligent decision about which trades are a little bit wacky over here. Let me put this down to 200. I saw something that increased the number of securities I was getting back, so the result is going to be a little bit different. CIBV, VENU. That's totally fine. Okay, so I was looking for these. VNU, STZ. So if I go back to what I saw before, VNU, STEZ. So here's the STEZ. That's one I kind of drew your attention to before. They have all these options that they're exercised. It's all zero value, right? So that is actually suspicious. This one over here for Intel looks like it could be suspicious. It's over $1 billion, but all this is really is Intel selling stock to itself or buying stock from itself. So even though $1 billion is traded, that's not considered suspicious. STZ is considered suspicious in the definition of this GNN because we had a bunch of trades all at zero values, right? So where's VENU? All these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 transactions all at zero value. That's why the model is saying this is suspicious. That does look suspicious. Like, why is this happening, right? Here we have VNU. We have 1135, so only a little over 1,000. And this is the person that did the transaction. This is another person. They sold 10,150, and this person sold 1,879, right? So this is actually considered kind of suspicious just because, again, when we go to the next step, it becomes more apparent here. If you look at VENU right here, you see some big price spikes right before the transaction. So the amount wasn't too much, 1,135. It's only $1,135, but the stock was up 15% in the month before the transaction. That's why this is flagged as true, right? So we have to do all this analysis to get the 1 month's return prior to the transaction. Look at the total value. Okay, is that big or small? These are all the STZ transactions. So what did we say? We had 11. They're all $0, and there's no big price spike. This is false, right? But it looks a little bit suspicious to the GNN model because you have 11 different transactions that had a total value of $0. So what's going on here? Like, why is it zero? That's an anomaly. This is an anomaly here because you didn't trade a whole lot of money. This is $10,150. This is $37,000. But the stock was up almost 15% in the 1 month before. So that looks a little suspicious. This guy was probably eyeing the market. The stock jumped up 15%, and he unloaded 10 plus 37, 47,000 in stock. Probably the price is up. He wants to lock in his gains, maybe take a little vacation, maybe have some money down payment for a vacation house. I don't know what the intention was here, but that's why it came off, right? So you had the big jump 1 month before and a lot of transactions over here. VNU again, 11.63. So the threshold again was 10%. Anything over 10% is considered a spike. Okay, so we have a spike there, and not big transactions. 1,437.7769. So altogether, even under $10,000. Not a big move, but the price was up over 10% the month before, so that's why it's flagged. STZ again is 0. This one's just bizarre. I can't figure out why they're exercising all their options for 0. And CBV comes up too. Remember, these are the three. So STZ, Venue, CIVB. Let me find that in the graph. CIVB looks like, I don't even know where that could be anywhere over here. CIBV. Okay. I think the only way to find it is just to eyeball it, because this graph is all based or rendered dynamically. CIBV, is that the one? Yeah. Okay. And I'm still not seeing it. Still not seeing it, but you know, I think that is okay. That can be anywhere. If you zoom out, there's a lot of these transactions, right? So if we can't find it, that's okay. It's somewhere in that graph. And this was flagged over here by the CNN model, or sorry, GNN model. So we looked at this. These are all zeros. This had a big jump in the price 1 month before. It's up over 10%. That was the criteria, right, for being price spike. And if I go back here and look for the logic, right here, so it's up 10%. That's where we get the price spike. Remember that we appended this onto the data frame around the beginning of the analysis. So we had the trade date 1 month return before the transaction price spike. And then we go down here. This is the 3 outliers. So that one makes sense. It's all 0. This had a 1 month jump in the price before the transaction. CIVB, let's see why. CIVB. So down 5%, not price spike, but you did have some pretty substantial transactions here. So 21K, almost 50K here. And, well, CIVB, so this is down again based on the transaction date, right? So now it's 7/15. We're going back to June 10th, right? Because the transaction was July 11th. We have to go back 30 days, but we actually went back 2 months to capture that. And I would say all of these transactions, let me see. CBB. Okay. Okay, so okay, so just trying to figure out why it's flagging over here. Down 5%. And there are some values over here, but nowhere close to that Intel transaction for $1 billion. So I'm asking ChatGPT. It just says all transactions are a buy, and all the transactions are on the same date. So that's kind of why this is an outlier, right? So you have July 11th for everything, all buys. And that's it, right? So, well, that's something else. This is buy, 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 and that's it. So the whole point of this analysis is you're looking for things that are unusual, some type of anomalous activities, right? You're not looking at these big trades for Intel over $1 billion. That could be considered okay. That could be unusual. That could be um, a rare type of thing. But the GNN model is not flagging that as unusual. It's just a large transaction, right? What we're trying to get at here is really the patterns discovered by the GNN. That's much more interesting and much more useful, right? So anomalies in this case are detected not by trade value or the size, but by the unusual graph structure and the node behavior learned by the GNN, right? So this is the AI tool that we're working with. It's not AI in terms of Hugging Face or ChatGPT. It's AI in terms of the connections of all the nodes and all the edges, which are the lines that connect the nodes, and all the relationships between those, right? So it goes in a different direction from traditional AI or traditional Chat GPT or Hugging Face or something like that, right? We want to understand the relationships between all these transactions. That's what's really driving this GNN to make this kind of conclusion, right? Where it says these three stocks have anomalous types of transactions, and we're trying to determine why. I think we did. So all the same trade date, or stock is up over 10% and people are dumping shares, or these are all zeros over here for STZ. So all of these have somewhat unusual trading patterns compared to the rest of the field there, right? So we're just using some basic Euclidean math, looking at the distance of the mean from all the other graph edges and nodes around that, a little bit like k-means clustering. K-means also uses Euclidean distance, but this is not clustering exercise. It's very different. It's a graphing neural network exercise, right? But again, like big trades may be frequent or just massive in size. Intel had over $1 billion, but that's not an anomaly, right? Node centrality or degree of nodes can often have well-connected edges or well-connected nodes, which is the circle between those, and the edges are the lines, right? But if those follow predictable patterns, it's not going to be spit out by the GNN model, right? The GNN model is really looking for STZ, which has a lot of transactions that are all worth zero. So why are all these people trading for zero? And venue comes up because there's a 10% increase in the stock price just before the trade, okay? And basically, let's say with CIBV rose, I'm going to add this into my analysis too. All trades. All high, CIBV. The pattern, and there was no pattern between the values. The values were always different, but the dates were always exactly the same. So that's a little bit unusual, and all different people were trading those too, right? If you go back and see the CIBV, you have Schaefer, Perfect Clyde. Apparently, that's the guy's name. Sounds like a weird name. I've never met anyone in my life named Perfect, but that's okay. Parcher, Roth. So this is the same person. So this could make sense. The transaction is on the same day, right? July 11th, same guy doing the trade. Maybe a woman. I think that's probably a guy though. Oh, I'm sorry. I'm looking at totally different stock. CMBV is here. So Schaefer, Perfect, Parker, or Parcher. We get down here, Congrove, Mulford, Morris, Morisi, and then Dutton. And again, transactions actually different, buys and sells, values all different, but all occur in the same exact date, right? So buy, oh, those are, wait. Okay, so buy, that's venue, that's different. Buy, 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 right? So all buys, all on the same date. It's kind of unusual, and all different amounts, right? So these guys could have colluded together and say, let's buy this stock. The price is actually down 5% in the past month. Maybe they're buying at a discount, buying on a dip, and hoping that the stock price is going to appreciate. Not sure, but that's why the GNN model flagged this as an unusual trade pattern. So that's it, guys. I just want to show you the ins and outs of GNNs. This is a type of type of AII. ANN is totally different. Type of AI tool called a GNN, Graph Neural Network, used to help us understand relationships between nodes and the edges of those nodes. In this case, we're detecting or looking for inside trading patterns and detecting unusual activities of trades. So that's it. I'm going to save this right here. So save as HTML. I always save these as HTML. I like the format. It's easy to interact with. You can open it, copy and paste the code into your own Jupyter notebook, and then run it and do whatever you want. So I've got the file saved down. I will post the file a little bit later when I post the video. So you have all the code, all the business logic. You can go ahead and run this for yourself. And again, change the time frame that you go back in time. So I'm looking at 2 months of historic data. If you want to go back further, you can certainly do that from the Yahoo Finance endpoint, right? If you want to change but I don't think it's going to matter too much. And I told you why before, right? Because we just have like 1 month of trades for the insider activities here. If you want to look for bigger spikes, you can change this number. What else? Yeah, if you want to change the start end date, you can certainly do that, or you can go back 3 months. I don't know if it makes any sense because all the trades go back just 1 month, but as long as you have enough to capture that, I think you're fine. And this, I don't think you have to trade anything here because there's no specific tickers that we put in here. I just went to this website and just fetched all the data from that. So really, the only thing that you might want to change here to see how the analysis changes is the cutoff or this metric right here to determine if there's a spike in stock price. Okay, so you can pretty much run the code as is. There's not too much that needs to be changed over here. So that's it, guys. I'm going to wrap it up. We already hit, how long is this? 42 minutes. That's kind of a longer one. I didn't even realize we're at 42. So I'm definitely going to wrap it up. I don't want this to drag on and on. Hopefully that was useful and insightful and very, very enlightening for you guys. I always try to make these informative and enlightening to the greatest extent possible. So I'm going to wrap it up here. I'll post the code and I'll post the video in just a bit, and I'll see you in the next one. Bye.